Okay, so this video is limits of logarithms. And so we have two limits that we're going to be looking at. With our logarithm graphs that are here, I have a bunch of them here, you can see that we have a vertical asymptote at 0. So we can either approach that 0 from the right, or we can go off to infinity. So those are the two limits that we're going to look at. So the limit as x approaches infinity of log, base any b as long as b is greater than 1, is infinity. So you can see that over here. It goes off to infinity. And then as x approaches 0 from the left, you can see it's going down to negative infinity. So those are the two limits that we get. And these are what we want to look at. So when we're doing these problems, this is what we want. We want to see log of some variable as it approaches infinity of that same variable with a base b bigger than 1, or 0 plus. Okay, so let's try one. So here you can see that inside has been changed to some other function. And so these are basically composite functions. You have some g of x sitting here that we're plugging into our logarithm. So we're going to take that function out, and we're actually going to call it t. T equals 8x minus 4. And then we're going to graph it. So you can use a graphing calculator to get this graph, or you can just use what you've used before, which is to factor it. Find your zeros, plot them on the graph, and then use its in behavior. So this is a negative x to the 4th, so we know it does that, and so we get this shape. Now we can look and see what's going on. So we are approaching 2 from the left. So we are coming in this direction from the left. So here's where it gets a little complicated. Not too much. Once you get the idea, you'll understand it. So this is what we're looking at for this function. We're coming in from the left. So what we want to do now is say our t is our new input. So we're saying the limit as t approaches what number? Log base 5 of t. So we're using that function. Remember, this is what we need. And obviously it's going to be infinity or 0 plus, because that's what we're looking at. And so if you look at our line, our red line is coming in, and what is our t? What are we approaching here? So as x approaches 2, our t is approaching 0. So our t is approaching 0. Now here's where the plus comes in. What are these t values? Well, these t values are positive. They're not negative. So we are coming in from a positive. And there you have it. So that would be which one? Exactly that one. So our answer is negative infinity. So you've got to think about it this way. Our x here is approaching 2 from the left, this side. So now what we're going to do is change this to a t and that to a t. So now we know our t is approaching 0. Now it's y values. So what are the y values here? Well, all the y values are positive. So it's 0, positive. And then now we can replace it with the t. See, what's happening here as x approaches 2, this is changing. And so now we just look at it this way. Think about it this way. X is our input. We're plugging x's into this stuff. So before they even get to the logarithm, our values here will be modified by this function t. So that's all we have to do is look and see what's happening with t. Now if you go, I'm just going to plug it in the calculator and look at it. Well, there's your graph. So it's not very obvious to see. The graph of the inside function is nice. The other graph is horrible. Now this doesn't mean you can't use your calculator to find the limit to make sure your answer is correct. But you have to use your table set. So we're going to be approaching 0, right, for our function. Actually, we're approaching 2. And we're approaching from the left. So you want to make your change in table negative 0.001. Now if you look at your table, you'll see it says negative 2.3. And you think, oh, well, that's my limit. Nope. Let's get even closer. So negative point, and we'll put a lot of zeros in there. You can see now it's negative 8. See how it's getting bigger. So as I get closer and closer to my negative 2, the number is getting bigger and bigger. There's my negative infinity. It's just a lot harder to see. So obviously that's not an easy problem, but if you do it a few times, it will become one. So let's try another one. So what I've done here is I've changed my 0, now it's plus, but we're going to be doing sin x. So again, we are saying this, limit as t approaches, and we don't know yet, natural log of t. And so I've already taken my sine x and made it t equals sine x. And we are approaching 0 from the right. So from the right side now we are approaching 0. So what is our t approaching? Well, t is approaching 0. You can see it right there. So t is approaching 0. And what are the y values here? Well, they're positive, just like before. So we're approaching 0 from the positive side. So now what does that give us? Same thing, negative infinity. And so plugging that entire function in, the natural log of sine x, you can see that it is approaching negative infinity as t approaches 0 from the positive side. But you got to do a little work here too. You can't just do this all with a calculator. It's got to have that you understand what's going on. All right, let's try one more. Here's tangent squared x. It looks just like this. And we already knew that that's tangent because it would normally do this, but then all the negatives are turning positive. So we know tangent looks like this. Now this one says tangent and we're approaching 0. So we have both left and right coming in, but they are both approaching 0. So our t here is approaching 0. See, again, this graph itself is what we're looking at for t. So our y values here are approaching 0. Y values are approaching 0. Just like up here, the y values are approaching 0. The y values are approaching 0. And you may be saying, yeah, they're all approaching 0. Exactly, because that's what we need it to do. And on both sides, they are both approaching from the positive. See, now if it was over here and it would be negative, then you would have to keep it as 0. But it's both approaching just from the positive side, log base 7 of t, and again, negative infinity. So these are all the same answers that we're getting here. So you can see even at 0 there again, it's going to infinity right there. So if you hit trace and 0, you'll see it's undefined. It does not exist there. So yeah, there it is, negative infinity. All right, so that's our first type. You're going to take that inside, you're going to make it into its graph, and you're going to look and see what's going on at that point. So as we approach 2 from the left, we are approaching from the positive side. As we approach 0 from the positive side, we are also approaching with positive values. So we got to use a 0 plus. And as we approach the tangent from the top and the left, so left and right, we're both approaching from the top, which are, again, positive values. So you're approaching from just the positive side. Okay, we can also use our limit laws, our log laws. So if we have a natural log and a natural log, same base, then we can rewrite it as a fraction, 1 plus x squared over 1 plus x, with the limit as x approaches infinity. Now that inside is a fraction. So we can take each of those and divide them by the denominator, which is an x. And we get the limit as x approaches infinity. And we're going to divide them all by x. So 1 over x plus x squared over x plus 1 over x plus x over x. Remember, we always divide by the denominator's degree of that polynomial. So that would be x in this case. And now we can say, well, the limit as x approaches infinity, well, that one's going to 0. That one's going to 0. And the other two simplify. So we end up with the limit as x approaches infinity of the natural log. I'm going to write the 0 plus x over 0 plus 1. And what does that become? Well, that's just the limit as x approaches infinity of the natural log of x. And now, natural log is e. It's base e. And e is greater than 1, so it fits our rule up here. So as x approaches infinity of log base b of x, we get infinity. So there is our answer. All right, let's try another one. All right, so on the last one, we're going to be using transformations. If you remember with any transformations of our parent function, so this one's a natural log, whatever's on the inside here, we're doing opposite. Right? And that's all I have to worry about with x. This is just the y value. We can deal with it at the end. But we want to really just focus on the x. So if I have x minus 2, that means I'm going to shift this to the right 2. Right? So if you had natural log of x minus 4, this would go to the right 4. And if we had natural log of x plus 5, this means we would go to the left 5, right? It would be our negative. So they're always opposite signs. So On this, I need to take this and go x 0 plus, but I can't use x. We really shouldn't. We should change the letter. I need this to be t approaches 0 plus, which means I need to shift this whole thing. All the x's need to go to the left. And so if I'm going to the left, that means I need to add them. So I'm going to take this minus 2 and add 2. And so this would become natural log of t minus 1. And then so that would just become negative infinity by our rule that we already know from up here. So as we approach 0 plus, natural log of, or log of our b, doesn't matter, is negative infinity. So this one becomes negative infinity. So if you just focus on that x, another way to do it is just shift that inside over and see what function we now have from it. You do have to change the letter though. So there we go.